In 9.2, we're continuing with sequences, and we're going to take a look at an idea called an arithmetic sequence. So what's happening here is that we are constantly adding the same number to each iteration of the sequence. And so there's a common difference between each of the numbers. So let's take a look. So what we're going to do is just find the difference between each step in this sequence. So if I look between 2 and 1, there's a step of 1. 4 and 2, there's a step of 2. 8 minus 4, I'm just subtracting a term from the previous term. And what I'm finding is there is not a common difference between them. So without a common difference, this is not arithmetic. So let me show you. So here in our next one, between each iteration, I'm taking the next one minus the one that happened before it, I find 4. The next one minus the one that happened before it, I find 4. And I continue in that fashion, and what's happening is between every iteration, I keep simply adding 4. Okay, so let's take a look here. So between the second iteration and the first, I get minus 2. Now, it's okay if it's a negative, that's fine. Thinking of it as like adding a negative number is no big deal. So we've got a difference of negative 2. Okay, let's do the next iteration, 14 minus 16, I get negative 2. This appears to be an arithmetic sequence. So I do the next two. So I'm doing this iteration, and the one before it I get negative 2, etc. So I'm getting a common difference every time. We just keep adding negative 2 to the sequence, to each term in the sequence, and we create it. So this is arithmetic. We have that common difference. Okay, let's try another one here. So I've got 3 minus 1. I'm taking the second term minus the first. I get 2. 6 minus 3. So I'm taking the third term minus the second, and I get 3. So I can already tell this is not an arithmetic because it's not a common difference every single time. An arithmetic will just add a number, the same number, to every iteration. So this is not. Okay, so we're starting here with the first number in the sequence, and they're telling us that the common difference is what this D is standing for. That common difference is negative 3. So if we want to generate the terms, we just have to, well, they didn't really do it, so we just have to keep subtracting 3. So the first one is 17. The second one will be 14. Take 3 away from that, now we've got 11. Take 3 away from that, now we got 8, etc., etc. So we just keep taking away 3 to each term in the sequence. Okay, same thing here. So we've got 1 is my first term. Well, 1 minus 5 is my second. So negative 4. Oh, I'm sorry, not minus. We're just adding. So 1 is my first one. 1 plus 5 gets me 6. 6 plus 5 gets me 11. 11 plus 5 gets me 16, etc. Okay. All right. Now, what we need, I think you're going to understand the logic of this here, but we're going to try to find a missing term in arithmetic sequence, but we're not going to have all the pieces that we need. We don't know the common difference because all we've been given is the first term and the fourth. So we don't have each term, so without knowing two successive terms, I can't find the arithmetic or the difference that I need. Now think about the logic of this formula. If you knew the first term, you just keep adding some multiple of that difference. So if I wanted the first term, it would be a1 and 1 minus 1 times that difference. Do you see that that would be, oops, do you see that would be 0? So we're just adding some multiple of that difference. The first iteration, we're adding no difference. So 1 minus 1 would be 0 differences. Now a2, we'd have the first one plus 2 minus 1. So n is 2. So we're adding one difference. Do you see how that will work out? Now I'll show you just one more here. So 3 minus 1 times the difference. We're adding 2 differences because we went from a1. So that was one difference. There's a second difference. So this formula is going to help us figure out what any particular term would be. So let me show you the work here. Yeah, here we go. So they want us to find, okay, so we're looking for the difference first. So we need to use this formula to help us find the difference. And so what we're going to do is we need just one I don't know. I need D to be the only thing I don't know. So look what we could do though. If we worked with A4 and A1, we can find just one I don't know. Here's what I'm saying. If we know A4, we know that's A1 plus 3 differences. 4 minus 1. 3 differences. So this formula now only has one I don't know, because I know A4 is 14. I know A1 is 8. All I have is D. I could solve this, find that difference. Now, they wanted me to find A5, but I know the difference, so it's easy. It's arithmetic. The difference is 2. I know the term in front of it. So 14 plus 2, A5 must be equal to 16. Okay, so let's do this again. So we've got AN is going to be equal to A1 plus n minus 1 times that difference. This is really just the logic. I know it looks like something just to memorize, but it's the first term plus how many differences do you want in order to get to this nth term. Now, this is going to be a little different. So we don't have A1 here. We're missing it. So we're going to have to do this as a series of equations. So what I'm saying is we cannot eliminate this down to just D. We're not going to be able to do that. However, we can get it down to 2 series. So let's do this. Here's what I'm saying. A3 is going to be A1 plus 3 minus 1 times D. So A3 is going to be A1 plus 2D. Do you agree with that? Okay, now we have A3, so we've got 7 equals A1 plus 2D. Now let's do it again for A5. A5 equals A1 plus 5 minus 1D. So A5 is A1 plus 4D. All right, well, we know A5 is 17. So I have this. Now, I don't know A1 or D, but I now have a system of equations, so I can solve this. So we could do it. Elimination might be easier. Yeah, I'm going to do this as elimination. So I'm going to put 7 equals A1 plus 2D right on top of it. I'm going to run a negative through here and then just add them up. So it's going to change all the signs of everybody there. So I'm doing 17 minus 7 is 10. A1 minus A1 is going to go away. 4D minus 2D is going to be 2D, so D is 5. Now I've got it. I've got the common difference. These terms keep changing by 5. So I have A3 and I want A2. Well, let's do it like this. You could just figure the logic. A3 is 7, so that means A2 is going to have to be 5 if there's a common difference. But if you don't see it, let's do it like this. So A2 is going to be A1 plus 2 minus 1D. Okay, so I know, looking for A2, it's going to be A1 plus 5. Okay, now I don't know A1, but I had a system of equations that could help me find. I think logically it would have been better to just think, okay, if you keep stepping 5 each time, if your A3 is 7, then A2 is going to have to be 5. But let me just finish this since I've done it here. So I've got my common difference is 5. Yeah, so I'll use this one. 7 equals 5 plus 2. Oh, sorry. 7 equals A1 plus 2 times 5. 7 equals A1 plus 10. So our first term was negative 3. So again, the logic of just stepping through would have been easier. But so we're looking for A2. We know A1 is 3 plus 5. And so A2 must be 2, which we could see if you just thought it through, what a sequence is. Okay, so this one, what was different is that we didn't have A1. So we had to create a system of equations, which we've done many times. We create 2 formulas that have 2 I don't knows. We created these. I then just did the elimination to just get the A1s to drop out. I could solve for D, and then I went ahead and went back and I solved for A1. So now I know A1, I know D, I know everything I need to use this formula here. So I have that formula. I was looking for A2. It equals A1 plus that difference, and that's how I came up with 2. Okay, I think that was pretty straightforward, and hopefully that made sense. So we're looking at arithmetic sequences. They have a common difference between each 2 successive iterations.